My name is Mano Marks. I'm a developer advocate at Google. That means this is my job. I get to come out and talk to developers around the world who are working with our mapping APIs. And so I'm really glad to be here. I noticed that BootCamp was billed as this small and intimate gathering compared to Google I/O, and I also noticed that there's like 1,000 people here, so I don't know how small and intimate everything is, but I hope you guys have been having a good time today. I am going to talk about a number of things related to mobile development. So first of all, how many of you have a mobile device? Okay, so this is a little developer advocate trick. You get everybody raising their hand at the beginning. Everybody feels like they're participating in something. It's a little trick that they teach you. The other trick is you let people in on your tricks. Makes them feel included. But really, I don't care about the tricks. I just want to show you what's cool about mobile devices. So how many of you have written an application using some form of the Google Maps API in some application? Okay, that's a good number. That's probably about 2/3. It's an interesting number. What I'm going to talk to you about here, you can obviously see what I've written up here, but the first thing we're going to talk about is what is different about mobile mapping. Why is this a different kind of talk than your basic how to get started with Google Maps on X platform? And then we're going to talk about the different kinds of options here. Now, there are multiple options. You can develop using native applications, native APIs. You can develop using our JavaScript API. You can do a combination of the two. You can use our static maps API. I'm going to go through all these different options and talk about why they are the same, why they're different, and what the different advantages are of each. At the end, I'm actually going to go through and do a comparison feature by feature, what the major features are and what you have on the different platforms. And you'll see from that why I recommend the JavaScript API. And then finally, I'm going to talk about some optimizations that you can use to make your maps faster. Okay, so what is different about mobile? So there's a lot of different things, obviously, about mobile. And if you take a look at the mobile devices that you have on your person right now, you've got phones, you've got tablets, you've got what else? You've got laptops. These are different things that you're carrying around with you, and they have very different screen sizes, very different form factors. So this is a lot smaller than a Motorola Zoom, and it's shaped differently. It's got different aspect ratios and that sort of thing. This is also carrying around with it connections, innate connections that it has to networking. So this has Wi-Fi on it, and it's got 3G and 2G. It's got slower speed connections for edge networks. It's got a lot of different kinds of connections, and your different devices have different connections depending on where they're physically located, what kind of device they are, what networks they are, what SIM cards you have in them, that sort of thing. So these are things you have to take into account. And a piece of that is what I'm going to generically refer to connections as latency. So you have these issues of latency. It's like, how long does it take for your map to actually display to your user? You also have to take into account things like user interface, what kind of interface interactions you get on a device. So mobile devices are new because you interact with them with your fingers, not with a keyboard, right? So there's a lot of different kinds of interactions, and different devices will actually pass different connections to browsers than they will to native applications. And there's just some things to think about there. I'm going to be mentioning that as we go along, and also doing some demos. You use these device services. So this is where you actually get a lot more power out of something like this than you do out of your laptop. You have a GPS device in this. I mean, think about a few years ago, 5 years ago, you've been carrying around a GPS in your pocket with, just in your phone. That would have been pretty incredible. So you're getting that, you're getting things like compass, you get contacts, you get all these sort of different kind of services that aren't necessarily available in a browser-based application. You also obviously have different operating systems. You've got Android devices. Samsung has its own BOTA interface. You've got the iOS devices. You've got a lot of different kinds of things coming down the line that have different kinds of operating systems. And each one of them has different programming languages associated with them and different ways in which you code. And the traditional solution on computers to solve that problem was Flash, because Flash is installed on some huge percentage of computers, like 90-some percent, 99% or something like that, but not on mobile devices. In fact, only of the major devices out there, I believe only Android devices support Flash. So obviously, the iOS, you can't use Flash APIs to connect to them. All right, so this was the landscape 2 years ago when I first gave this kind of talk. When we first introduced the Google Maps API version 3, we had a fairly simple way to explain what you did with what you could do with the different devices. And you see there, that's a G1. That's the first Android device, and this is the first iPhone. On the far your left there, you have I just put up a Nokia phone. It's like a feature phone that's got a basic browser in it. But you don't have access to Google Maps through any sort of other programming interface. So using the basic browser with no JavaScript, you need to do something like the Static Maps API. Then you have native APIs that are available in iOS and Android. So that is, if you're an Android developer, you use MapView. If you're a iOS developer, you use MapKit. And our suggestion was to use the JavaScript API, which could be used on both of those. But the situation's changed a little bit in the interim. You've got a wider variety of devices now, some of which are coming along, and they're smartphones, but a few of which don't even use either Android or iOS, like the Samsung BOTA. And you've got these powerful tablets coming out that have also these very different interfaces. They have different ways in which people use them, interact with them, carry them around. So these are just all the kinds of things. I like to put this up towards the beginning to remind you sort of what we're talking about. We're not talking about just a map on your phone. And because I'm with Google, we're not just talking about, an Android device or a few Android devices, but actually there are, dozens of Android devices on the market and many tablets coming down the line. Okay, so let's get back to latency for a minute. I like to sort of highlight this. Now, there are basically two kinds of latency. And remember, again, latency, I'm basically talking about the speed in which something loads, an application loads. There's two kinds of latency. One is the actual latency, the time it takes to load a page or an application on your device. And then there's the user-perceived latency, which is how long the user thinks it actually takes. And you want to reduce both of these. Obviously, the first helps with the second. But there are tricks that you can do that help with the second while you're trying to help with the first. So let me give you an example. And I give you this as an example because, one, we like to talk about our JavaScript Maps API, but two, because these are techniques that, on the next slide, I will show you that you can also use yourself. Before I get too far into this, let me mention how many, you're all going to Google I/O, right? Okay, there's a talk, I think it's tomorrow. It's called Speedy Maps. And the Speedy Maps talk will go into greater detail on a lot of the pieces that I'm going to discuss now. But if you can't get to it, I'm going to go into some detail just talking about what. But this will be actual engineers on the JavaScript Maps API who can tell you, in great detail how you can speed up your map. But here's what we did when we switched from version 2 to version 3 of the Google Maps API. We totally rewrote it. And we did it in such a way that it would be optimized for mobile devices, because we knew that that was the main way in which people were going to start interacting with our maps. So first thing you do is you load only the code that is necessary. In version 2 of the API, the central map object knew about everything. If you wanted to put a marker on a map, you said, oh, take the map and put a marker on it at this location. Now, if you just want to put a map, the map knows nothing about markers. All it does is it downloads some stubby interfaces so that you can then load down code that you actually need when you need it. So if you need to load the code for a map and a marker, it only loads the code for the map and the marker. If you need to load driving directions, it loads that code as well. But only the code that you actually need, which is different from version 2 of the API. Reducing the file size, reducing the number of files going down the line. Another thing we did was we load a static map first. First thing we do, we put in a static map that looks like your map. A static map is just an image, a straight up, single image of your map with, whatever the basic markers are beforehand. And the reason we do this is so that the user sees something happening, reducing that user perception of something going on. People are more forgiving if they can see an actual map. They can go, oh, I can see that. They may try and interact with it and quite can't do it yet, but that functionality then gets loaded behind it, and the static map then goes away, and people can interact with it. So load the static map first. So the hint there is when you're doing something in a mobile application, load something that shows up before, while you're doing something, to give people something to do. And then the other one, and this one actually surprised us quite a bit, is package your downloads together. The greatest determinant, actually, of how long something took to load was how many files were downloaded. It was a much greater determinant than the actual size of the downloads. If you downloaded 4 250 kilobyte files instead of one megabyte file, whatever, 1,000 kilobyte files, the 4 files would download a lot slower than the 1 file. And this is because the browser does things sequentially, right? So if you package it all up together, you load it once. And you can do these things yourself, right? If you're writing JavaScript or you're writing code or you're making server calls, package things together in course downloads. These are things you can do to help optimize your maps. Load the static map first. Load only the code that you need to load to do the things you need to do. And there's a couple other things that we suggest, and I'm going to talk more about this one later, the use clickable image overlays for larger data sets. And I'm going to talk a lot more about that, but this is one of the key optimizations that you can use for mobile devices. Okay, so that's the basics of like what's different and the kinds of things that you have to be worried about more for mobile devices than you do for desktop devices. So development options. Just to review this again. Native applications, we're going to be talking about if you want to write a Google map in native code, your two options are MapKit on iOS and MapView on Android. For our JavaScript Maps API, you can use it in any WebKit-enabled browser. I've got a list there. There's a list in the documentation. It's bigger than iOS and Android. And then for non-JavaScript browsers, the Static Maps API. OK, so let's talk a little bit about the advantages and disadvantages of native apps. And I'm trying not to wander too far over here, because I think that's bad for the video. Sorry to the videographer. I tend to wander a lot when I'm talking, because I get excited. Also, I've had a little caffeine, so woo, things are exciting. OK, so MapKit. MapKit on iOS is an actual Android product. An Apple product. It says Google Maps, and they do use our services to do it. I just need to point this out. We don't actually provide support for it because it's technically actually an Apple product. It still gives you a Google map. You get the Google, the very nice map tiles that we provide and a bunch of other things. We provided them with a version of Google Maps for mobile, and they then went and customized that for their own use. On Android, you use Map View, which is something provided directly by Google. So the advantage of these two SDKs is that they are native code. They can be, therefore, more easily integrated with a native application. If you are writing an Android app, you're writing an iPhone app, you can directly integrate these into your application, and it's the one programming language, right? In Android, it's Java or C or whatever you're using to write your apps there, and it's Objective-C for iOS. And the advantage of integration is you don't have to learn JavaScript or something other language to load something. There's a bit lower latency because when somebody actually downloads the app, once it's actually downloaded, then you've got natively running on their phone or their device that code. So they don't have to go and reload it down whenever they load a page. This discrepancy is actually starting to lessen some as the JavaScript Maps API gets to be more powerful or faster, but there's still some latency there. You get full user interface support. So all the interfaces that are custom for that device are supported natively in that application. So what do I mean by that? So, whoops, sorry. If you do pinch to zoom, for instance, on a Android device, you will get pinch to zoom in your map view. So somebody can just literally pinch on the device. That is not passed through to the Android browsers, and I believe it is passed through to the iPhone browsers. So you get this, in native code, you get access to all those kind of events that any application can take advantage of. You also get another thing, which is discoverability, right? If you want to put your application in the Android marketplace, you want to put your application in the Apple Store, then in the App Store, then you get people can find it there. Of course, you're competing with all the other devices, the other applications that are out there, but it's not web search, right? So it's a different kind of discoverability, and people are still using that as one of the main ways in which they find out what apps to use. On the other hand, you do have to go through the approvals process for these different platforms to get your applications out there. That's OK. I should strike a dramatic pose for the photographer. There's in the video land, there's a photographer down there. I'll try and do it naturally. OK, so what are some of the other points? If you want to write an application that works on both Android and iPhone, though, that means that you're recoding that map for every platform that you're doing it on, right? So you're writing an iPhone application, you're writing an Android application, blah, blah, blah. It's extra work, and And when you want to update that application, you have to update the entire application, right? You have to do an update that somebody has to then download through the marketplace, through the App Store. Which means that it's going to happen less frequently, and your users, that map portion of your application is going to be different on the different ones. And finally, there are many fewer features within the native APIs than within the JavaScript API. And that's because for the JavaScript API, that's all we're doing, is making new features and making it better. Okay, so browser-based APIs, let's talk about the differences there. So I've got a list here, the Android, iOS, Samsung Dolphin, the BlackBerry 6. These are platforms that are currently supported by the JavaScript Maps API on different browsers. You do get access to some native phone features, particularly geolocation, which seems to be one of the primary ones for mapping applications. You can access other HTML5 features like local storage and all that sort of thing, depending on the device and the availability of those features. I call this the write once, tweak everywhere, because of course you're going to have different devices, have different screen sizes and different UI constraints. You don't get access to all of those UI features. As I mentioned, in Android currently, you don't get access to that pinch to zoom kind of functionality. So that's something to just take into consideration. It also looks slightly different, right? Both MapView and MapKit are designed to look like native applications, the interfaces, and look like an Android or iPhone application. The browser application doesn't mimic those UI features in quite the same way. But one of the key things that I think of that's really different about this is that you get really rapid deployment and development of the application. JavaScript and HTML are very simple, and you can push it out to your server. You don't have to update your application. You just have you just have people load a new version of it. Downside is you don't get the discoverability, the App Store Marketplace discoverability, but you do get access to. You don't have to do the approvals. Sorry, is what I was trying to get at. Okay, so let's just look at the basic code. This is your basic code for creating a browser-based application. You'll see here. I don't know. Probably in the video you won't be able to actually see my red dot on the screen, but you'll see here, this is the loader. So you're loading the script tag, maps.google.com maps API.js, and I've added this parameter sensor equals true. We always ask that people add a sensor parameter because our data providers require it. If you're using the GPS or something in the device to say, here's where this person is located, then we ask that you add this sensor equals true, otherwise say sensor equals false. That does not give you any benefits of the sensor itself. There are other ways to get access to that. I just always mention that. Then you set a variety of options. In this case, you're just setting the zoom level. Higher numbers mean you're more zoomed in. Lower numbers are farther out. And then the map type. So in this case, I'm setting it to a road map. And then I create the map and basically just say assign it to this div in the HTML, pass it the options that I declared there, and you've got a map. And that's it. The basics of doing HTML5 geolocation are right here. This is, you can just ask if this object exists, navigator.geolocation. And what it'll say, it'll return to you is whether or not that's true, that object exists. If it exists, then you do something with it. And this is the very basics of doing something with it. Navigator.geolocation.getCurrentPosition says, okay, you have the object, now find me that position. And when you do, you pass this function here and you do something with it, right? And in this case, this code will actually say, okay, set the center of the map to that location. There are many different things you can do here. One thing I want to point out is when you do all of this, when you put in this geolocation, when the user loads it, the browser will ask the user, is it okay for me to share your location with this application? It'll be just the first time that they load that application. And actually, I'd like to switch over to the Elmo, if I could. So I've got here a Motorola Zoom. And I'm going to apologize. The focus doesn't seem to be working very well on the Elmo. This is actually really nice on the Motorola Zoom. But you'll see here that I've already given it my permission to access my location for this, this site. So what I'm going to do here is I'm going to zoom in a little bit. And you'll see it actually did a pretty good job of finding where we are. Well, I wish you could really see that. But this is, trust me, this is approximately where we are. Sorry, the projector's not doing a great job of picking that up. But you'll notice there's something else here that I put this gray circle around it. Now, I did that because geolocation actually gives you something a little bit more interesting, which is it tells you how accurate it thinks that location is. It tells you, you know, all you have to do is say on the position, give me the accuracy. It'll tell you within how many meters it thinks it has it. Now, it's up to the device to figure out how to give you that information. You can also ask it interesting things like, how old is this position? How many seconds ago was this position taken? And things like, are you using coarse or fine-grained accuracy? Basically, is this assisted GPS, or is it just Wi-Fi-based geolocation? These are different questions that the device figures out how to answer and then passes you back that information. So you can get some really rich, interesting information just from the basic HTML5 spec. Now, people always ask me, what's the support for the Maps API for geolocation? And I always say, you don't need it. It's in the HTML5 spec. OK, so let's switch back to the computer. So I want to talk about one other option for smartphone development, and that's the hybrid application. That is basically a native application that, that runs a browser within it. So this is basically, you create this native application that creates a shell around your map using UI WebView in iOS and WebView in an Android device. This gives you some of the advantages and all of the disadvantages of both systems, almost all. I call it the worst of both worlds and also the best of both worlds, but you know, mostly what people hear is the worst. You have decent UI integration, and you know, you get the discoverability on a variety of platforms, both in web search and in the marketplace. But you still have to write these native applications. This is currently our suggested method for most developers, because most developers are wanting to learn but the different platforms as well. But you know, your mileage may vary. The Google I/O application that you may have downloaded from the marketplace uses this method for the map. I may be running a little bit out of time, so I'm not going to go into great detail on the code, but these slides will be published. There's also an article on our Maps API documentation about how to do this. But basically, you know, you have to do a web view layout. You have to give permissions to internet access, of course, for your hybrid application. And if you want to get access to location data, you have to give permissions for coarse and fine-grained location. And then this is the basic code. You basically have to create a web map activity and set up your web view, and then you just load the URL. So it's actually, it's a bit more involved in that, particularly if you want to expose some other native services like contacts or geolocation to the device. To your JavaScript page. But this is your basics for setting up the code. OK, so let's talk quickly about feature phones. How many of you have feature phones, that is non-smartphones? Okay, not very many. But most people in the world do, right? Most people in the world have feature phones. And for many people, that's the sole way in which they access the internet. Now, what I mean here is, say you have a dumb browser, and I don't mean that in a highly pejorative way, but a little pejorative, that is, that it can't really handle full JavaScript support. Or they might, this is also an option for you when you're operating in very low bandwidth environments. Using our static maps API, you can get a very lightweight map server. Now, it's non-interactive, it's just an image, right? You specify things like, you know, how big you want it, what color the markers are, that sort of thing. It's fairly fully featured, except that it's again, not interactive. But it's fast, and that's the key here. Very small, lightweight tiles. And this is basically what it looks like. It's just a URL, right? And within that URL, up to 2,048 characters, you can specify a map, and you get a map back. And here I've specified things like Brooklyn Bridge, New York, New York. So you're doing a little bit of geolocation. You can actually say, center it on an address, rather than centering it on a specific geolocation. Zoom, level, size, the map type, so satellite or road map or whatever. And then I'm actually specifying markers at different locations and different colors for the markers. You can even do things like specify custom marker URLs. So if you have something that's for your application that you use, you can specify those custom markers. You can add in polylines, you can add in polygons, you can do really interesting but non-interactive stuff and return back a very fast, lightweight application. Okay, so let's go through some of the feature comparisons here. I've got 2 slides of this, and the bottom line is that first column, the JavaScript Maps API, has tons of features that are not in any of the other APIs. Everybody does the basics, except you'll notice one here, geocoding seems to actually be missing from the map kit. Geocoding is the process of taking an address and turning it into latitude and longitude. So that's their choice. They chose not to expose that through MapKit. But you can do interesting things like these KML GRSS layers, driving directions, traffic, circles and rectangles, custom overlays, image types, custom map types, fusion tables integration. The list is actually longer than this. Styled maps, that's another fun one. The list is actually longer than this. It just didn't feel like going on for slide after slide of the JavaScript features. So there is one interesting data point right here, which is navigation. So the Android devices actually allow you to do this thing, which is launching things as an intent. How many of you are Android developers? Okay, so you can, other applications can expose an interface that you can say, just launch this application. It's not really an API, it's just, pass me some information and I will give you access to this application, you can launch it. Navigation, which is that turn-by-turn directions that you can get on Android phones, is exposed through as an intent in Android devices, and that is the only platform that's available on. So I do want to fess up, that is the case. Got some optimizations, but I want to go and do another couple of demos here for you. So if we can get back to the Elmo. If we could go back to the Elmo, thanks. Okay. So I showed you this geolocation, but let's take a look at this here. So this is a little bit harder to see because this is not a fantastic presentation, but if you were to see it on the actual device, this is nicer. This is a Google map, and you'll see it's actually in black and white. I deliberately optimized this map to take away a lot of things from this map, and one of the things I took away was color. So I changed everything to black and white, and I took away most of the points of interest, and I took away all the roads. I left on the transit lines. This is actually in Japan, and I chose that because Japan's very dense in the maps, and this is what the map looks like normally. Now, that's a lot of information that's missing in my styled map. Go back to this same location, this styled map. Now, the reason I did that, by the way, is to declutter the map. Now, on this huge screen that we've got here, you see a lot of information, and that's generally considered to be good. But what if you're doing it on your phone? And where did my phone go? There's my phone. What if you're doing it on something this size? If you have all that information, you're exposing the user to looking at all that information and trying to parse through it. If you can declutter your map, then that's an optimization that you can use to make a better user interface for your user. You can also do things like change the color so that it matches the color scheme of your website or something else, for aesthetic reasons. And I also wanted to point out this. So again, usually a lot cooler. If you view this site actually on your device, this looks a lot sharper. But this is Google Street View. And you see if you move around in Street View, and my connection's pretty slow right at the moment. But generally, when you're moving around in Street View, you see streets, right? So one thing we add, which is only available in the JavaScript Maps API, is this custom street view. So this is the indoor offices of the Sydney office. This is a Maps API site, and they basically just took one panoramic photo and put it into this Maps API site. And you'll see that it's actually integrated with the controls. So I can go back out to the road and view the road. So Street View available to you through the JavaScript Maps API, and it's served up using HTML5. So you get to see it on any browser. We did that deliberately because Flash wasn't supported on many mobile devices. Okay, I want to talk about another kind of optimization. And this is kind of a two-parter. So you may remember back at the beginning, I talked about doing clickable raster overlays to show large amounts of data. Now this is a Maps API application running just on my own website, and it's using the Fusion table layer. Now what Fusion tables is it's how many of you have used Fusion tables or know what it is? Not very many. Okay. So Google Fusion tables is a way for you to upload large amounts of what we call vector data, that is, tabular data. Spreadsheets, databases, CSV files, and and KML files, and put them store them on Google servers, and then query them using Google's using an API or directly into the Google Maps API. And what happens is Google will render these as map tiles. So this is not rendered as JavaScript objects within the browser. It's rendered as a single image tile, or actually multiple images tiled, the same way we do the tiling for the map itself. So notice when I move the map here like this, you'll see you will see different, if I move it places I haven't actually been, you'll see that part of the map will not be exposed, and then it will come in. You see there where it's drawing Alaska there. The idea here is that you take an image to represent all your markers and all your features, and it's a lot smaller than creating JavaScript objects for every marker or feature. There's a talk on fusion tables, I believe it's tomorrow, and James McGill, who's doing that, did some tests. I'm going to preview this for you. He took 100,000 markers on a high-end MacBook Pro using Chrome, so the best environment for rendering that. Rendered it within the browser, and it took 34 seconds to render all those markers. Now, anything less than that setup, and probably the browser would have just choked on it. Using Google Fusion tables and rendering it as these clickable overlays, 100,000 rendered in 3 seconds. And the map was actually usable. See, the other thing that happens when you render 100,000 markers, or any large number of markers onto the map, whenever you move the map has to move all the overlays. Whereas if you're doing it all as one image, then it happens more quickly. So again, more details in both the Speedy Maps talk and the Fusion Tables talk. So within JavaScript, and again, this is because of the projector here, it's not rendering very quickly, but you can actually dynamically interact with this layer through the query object. So here, I'm just using a slider, and what I'm doing is I'm taking, this is a map of congressional districts in the United States and by population. And the color of the polygon represents the actual population. And I'm doing a query, which is hard to read up there, but it's a SQL query, right? So it's basic SQL query, SQL, saying select the shape column, that is a column that describes the congressional district boundaries here. And then it says and it gives a table ID. And where, so these are just straight up SQL, the median age of the total population, that's one column, is greater than a certain number, the number being generated by the slider when I click on the slider. So in this case, these are all the places where congressional districts have median population greater than 40. You see there's a lot of them in Florida. Okay, so if we could go back to the laptop, thank you. So, optimizations. Create these clickable raster overlays. And there's 3 methods of doing that using Google. One is to use the Fusion tables. That is currently the best way. You can also use your own KML or GRSS files and create what's called a KML layer in there. We'll create these highly optimized rasters for you. And when you click on them, you can actually get click events back. Cache your data and your tiles locally. We have an article on our documentation that shows you some of the URLs that you can use to cache the tiles. You can't access them directly, but if you just use the cache manifest for performance purposes, you can cache those tiles so that every time somebody goes back somewhere, they don't have to reload them. Use your HTML5 features like local storage and geolocation. And compile your code. How many of you are familiar with Clojure, Google Clojure? Not many of you. Okay, this open source library for compiling JavaScript. You ever go to a website and you're like, oh, I just want to view source. How many of you are JavaScript developers? Okay, you go and you view the source and you look at it and you go, whoa, what was that? Because you can't read it, right? It's just one big block of compiled text. That's because it's gone through a compiler. Process that's also known as minification. So the compiler strips out all the human readable portions of it and turns it into something that is dense. Not readable, but the browser can still interact with it. This minified code is much smaller, so it's reducing your file size. other optimizations, do be flexible in your styling, right? We already provide interaction. So if you go to a Maps API site using the default user interface, and it's on a very small device, we'll give you a smaller controls, and if it's on a larger device, we'll give you larger controls, completely dependent on the size of the div. But use a flexible screen size. Don't set pixel sizes for your height and weight, but use percentages. And on a small device for your map, you probably want to use 100%. Takes up the whole screen. And some people like to try and match the native user interface. There are some CSS libraries out there for actually matching the iOS screen size. Or, I'm sorry, screen representations. So I've got links in here to a number of articles and a video at the bottom for doing these kind of optimizations and developing for mobile devices using Google Maps API. This will be, I assume these will be published somewhere. This is our speaker meter. So, please give feedback on the talk. I'd really love to know what you guys think about it. It's just, speakermeter.com talks mapping-mobile-devices. And these are the hashtags Geo and IO BootCamp if you want to tweet about this. So at this point, I am now going to take questions. And what I'd appreciate is if you do want to ask a question, if you can use the mic so that it'll get recorded onto video. So thank you. Sorry, I was staring right into the sun there. Yes, go ahead.
So for a native Android app, you're suggesting we use WebView?
Yes. The question is, for a native Android app, I suggest that you use WebView with the JavaScript API. The Android people might suggest something different, but this gives you a lot of different advantages. Yes, next question. Go ahead, and I'll just repeat your question.
I'd like to do an app where I have my coordinates, and I want to know within quarter-mile pizza joints, and all those pizza joints are in a database.
Mm-hmm. Yeah, so you want to, let me see if I'll repeat your question and see if I make sure I'm getting this right. You want to find all the pizza joints that are within a certain radius, right? Yes, so Google Fusion Tables would be able to do that for you. So you upload your data to Fusion Tables. You can upload it in a CSV file or a spreadsheet or a KML file. Just have the geolocations within it. Or you can have one column that has the address, the address, and use that and geocode that column. And then in the Maps API, you saw the thing I was showing you with the census data. That's loading in data from Fusion Tables with the Fusion Table layer. And you can do 3 kinds of spatial queries on Fusion Tables using an SQL syntax. You can do a radius search. So you can say, give me everything within X number of meters of this one point. And what it'll do is it'll give you an intersection. So if you're looking at polygons, it'll actually show you polygons that intersect that radius, not just are wholly contained within it. You can also do a bounding box. You can say, here's a rectangle defined by 2 points. Give me everything that intersects with that. You can also do nearest neighbor. So you can say, give me the 50 nearest points to this point, or the 50 nearest features to this, this particular point. Yes?
Sorry. You mentioned that the navigation data is available only on the Android API.
Right, and to be clear, it's not navigation data. You're just launching the navigation application directly using an intent.
Oh, okay.
So you don't get direct access to navigation. All you're saying is, hey, we've loaded this up. Do you want to view this in navigation and navigate directly there?
So is there an API to be able to say, start address, end address, give me the KML, or give me the information that makes the blue line that gets you from here to there?
Is there a directions API is what you're asking? Yes, there is.
Okay.
So when I say navigation, what I mean is that turn-by-turn navigation that reads out the directions and kind of moves, animates your
Gotcha.
movement along the
Yeah.
map. Yes, the JavaScript Maps API provides driving directions. The Android map view provides driving directions. We have a web service that you can pass to addresses or geolocations to and say, give me back driving directions. And when you do that, it actually gives you all the different steps there, and that allows you to draw that directly on your map. Or you can just use the JavaScript API that will draw it on your map.
Okay, and will it give you back all? I mean, I don't, the geotagged locations of each of the turns.
Yes. So the directions API, you can query it to get the steps, and which is the steps contain the line segments
Gotcha.
between each location, and also the individual points in which you do the turn. And you can do things with that, like you can manipulate them, right? You can do driving directions and say you happen to know that you have I'm going to say an amusement park or a park or something. And you can get, by the way, you can get walking and bicycling directions as well. So you can say, okay, drive to this location, and then you can tack onto it, and then go further using walking along this path that I've defined myself.
Very good. Thank you.
Sure.
Can you comment on Google Places and how to translate a location, a latitude and longitude into a business?
Can I comment on Google Places and how to translate a latitude and longitude
How
to
to
business?
get the real content.
And the real content. So last year at Google I/O, we announced Google Places API was going to be launched, and it hasn't yet been launched. So unfortunately, at this point, there isn't, but I suggest at I/O that you ask Tor Mitchell about the specifics about that. We kept it in a very limited private beta. We weren't ready to release it at that point.
Are there other public sources that a person might use?
Are there other public sources for Places APIs? Yes, there are Facebook, Yelp, a variety of Foursquare, the Simple Geo. There's a variety of other sources for place data as well. Hopefully, we'll have the Places API really soon.
What are your recommendations for writing apps that need to use maps but offline? So you've got a tablet that's only Wi-Fi or something, and therefore...
Mm-hmm. So the question is offline maps, and what is my recommendation for that? I don't have a great recommendation for that. And to be frank, I don't think anybody really has a fantastic recommendation for it. We are limited by our data providers to not giving out the base vector data of our map. So we can't give you all the information about where all the roads are, for instance. So that would be something that would be necessary for doing that, for drawing your own maps. If you can find that data, and there are sources of data on this that are less complete than ours, like OpenStreetMap or a variety of other sources that will provide those things, you certainly can. That's a complex app that you can write yourself. And there are some options in Android Marketplace, I know, for offline maps. One thing you can do is if somebody's going to be offline for a relatively short period of time, you can cache in the mechanism that I described before. You just use the cache manifest to cache tiles. And I was approved last year at I/O to say, if you want to do something like load driving directions and then in an offline div, walk through all those driving directions so that it caches the tiles that are necessary for that. So that when somebody tries to go back to it on your application, but they're offline at that moment, then they can still see the tiles. There's not a lot of good answers to the offline mode at the moment. You could also do that with the Static Maps API. But just to emphasize, you can't directly access those tiles from the cache. You can just let the application re-access them. Any more questions? OK, great. Well, thanks so much, and enjoy the rest of the conference.